Hi, everyone. Okay. I will start in 3 minutes. Sorry, I am late. Let's wait for other students to come. Okay. Okay, I think we are all here. Okay, we are recording. Okay. It is weird that I cannot see you and I cannot hear you. Is everyone okay? And can see me? Okay. Very nice. Okay. Okay. Okay. I will share my screen with you. Okay, desktop. Okay. So previously I sent you this gradient descent notebook from Colab. Okay. And I will send you now another notebook I want to share with you. So I will try to do it. Share, get link. Okay. Only people that can open this. This can be. Okay, also. Open link. Okay, for the moment, I will share this new notebook from the chat, Zoom chat. I send it to you. Okay. Okay, so this is weird to make a code like this. Okay, I want to ask you, how many of you are familiar with deep learning? So have you ever written a code in Keras, TensorFlow, or Pytorch, or maybe from scratch with NumPy? So anybody, is there anybody who has done some work on deep learning? Can you write from the chat? Can I see the chat? Chat. Okay. Okay, I don't see the chat. Where is the chat? Okay, now I see. Not actually, just introduction parts. Okay, I haven't. İlyas say I haven't. Mehmet say okay. Okay, I think there are some that you are huge in numbers. I think there are up to 50 students here. Somebody should have code in Python, I suppose. Okay, but nobody wants to say it. Okay, can you open the Colab that I sent you, the Jupyter notebook that I sent you? Can everyone open it? Okay, I show it to you here. Okay, so this is the notebook. I suppose you can see it. So if you are ready, I want to start to the course. Okay. Okay. So I want to start with a quote from a very famous and important person, which is Herbert Simon. He is a Nobel laureate, Nobel Prize. He has won the Nobel Prize. He is a very important person in various disciplines. He's a multidisciplinary person from economics to artificial intelligence. So he says that, so what we want to solve a problem, and we want to use tools. From the beginning of the human history, we want to solve problems. And now we have a new tool that is called deep learning. But before it, what is problem solving? He says that, Herbert Simon says that it is solving a problem simply means representing it so as to make the solution transparent. So you just take a problem and transform it into a solution. You made, this is what we call feature engineering. So in machine learning, this is called feature transformation. We create some new features. With this new look, we can have the solution. So, so what is feature engineering in machine learning? It is coming up with right transformations, sorry, so that the downstream algorithm can solve a test. So we take the problem, we take the input. Input is what we know, and we transform it to output. Output is what we want to know. So there is something we know. From it, we will transform it to what we want to know. So, for example, for house price prediction, the price of the house. So what we know about the house, the size of the house, the location, closeness to the metro, for example. So we know something. So from this input, from what we know, we will transfer it to what we want to know. And it is the price of the house. And if we know it, if we know this transformation, now we can predict the price of the house. Okay. So deep learning is changed everything. It disrupted machine learning. So deep learning, actually, it is a subset of machine learning, but it changed things a lot. So before deep learning, as you see, for example, this is a classification task in this figure. Can you see my screen and can you hear me without problem? Is it okay? Okay, very nice. Very nice, thank you. Okay, so you see in the first part, the machine learning part, you take the input. This is not a house, this is a car. So you take the properties of the car. So what is its model? What is its type? How much kilometer it has done so far? So there are some properties of the car. So what you do as a machine learning engineer, before you need to extract some features. Features are something that is helpful to solve your problem. So you transform it. You make some transformation, then you give it to an algorithm, classification algorithm, and it says that it is car or not. So this is, if it says it is car or not, it is a classification problem because there are multiple categories, maybe the car, house, cat, dog, like that, and you this algorithm recognize it, and it says that it's actually, this is an object detection problem. You just classify this as a car. So which is the category of this object? But which is the class of this object? So this is classification problem. So there are some categories, discrete, 1, 2, 3, 4, like that. In that case, your algorithm predicts one of them. So this is called classification. But if you try to predict the price of the car, then it is a regression problem. So because in regression problem, you are just want to predict the price of the house. Maybe it is 200,000 Turkish lira or 250,000 Turkish lira, like that. There is no category, there is no class. It is just a real number that you want to predict. In that case, it is called regression. So does everyone understand the difference between regression and classification? Classification, there are some categories, you select the right category. In regression, the thing you want to predict is not a category, it is a real number. It can be any real number. So do you understand the difference between classification and regression? I suppose, okay, very nice. So I want to continue, what was I talking was the difference between machine learning and deep learning. So in the machine learning, there is a man here, sitting here. There is a engineer that extract the features for the input. So in deep learning, there is no feature extractor. There is no need for a man, for a researcher or worker, human worker that needs to extract features. Deep learning does it by itself. So this is the difference. No, there is no handcrafted features. There is no need for handcrafted features. Deep learning understands it by itself. I will continue because I know for most of you it is not clear. So what is the role of this man, and what makes deep learning, how deep learning get rid of the need of the feature extractor? Okay, now with this figure, I try to explain it to you. Okay, so this is a face detection problem. So you just give the face of a woman here, and there are, this is an image, and it is composed of pixels. So there is a width and height, and there is a channel. Width and height, the size of the figure, maybe it is a small figure, maybe it is a big figure. Channel is in image recognition, it is red, green, blue. So there are 3 channels. But if it is just black and white, then you have only 1 channel. If it is if it's an image with color, then you have 3 channels for red color, green color, and black color. Okay, so you give this image. Actually, this is an image. This is a matrix. This is a matrix, width and height. The matrix has a width and height. Okay, and each pixel has some numbers in it, and these numbers are between 0 and 255. Okay, 255. So this is a matrix, and if this is a color image, then you have 3 matrices: matrix for red channel, matrix for green channel, matrix for green blue. So you have 3 matrices. And when you have this 3 matrix, it is a special name. Do you know it? The data structure that has 3 matrices. Do you know it? Can you write from here? Somebody knows it among you. So matrix with many dimensions. What is it called in deep learning? Do you know it? Yes, tensor. Thank you, Avni Burak. Okay, so there is if you have just a number, it is called scalar number. If you have a collection of numbers in 1D, it is called vector. If you have a collection of numbers in a 2-dimensional array, it is called matrix. And from now on, from the 3rd dimension to the n dimension, it is called tensor. Tensor is very important. Okay, it is a fundamental data structure. Okay, at the end, so we have an image, and it has a matrix representation. Now, and what as I told you before, as Herbert Simon says, solving a problem is just representing it to make the solution transparent. Actually, we make this is the input, this is what we know, and at the end, this is what we want to know. So this is what we know, the image, and at the end, this is what we want to know, input and output. So we say that it is Sarah, it is Joseph, like that. So it is someone, and we want to know the name of the person. So what we know, so this is the input matrix or tensor, and we make transformations in deep learning. So this is a matrix, and what we do here is just a matrix multiplication. There is something here that you don't see. There is a weight matrix. So this is the input matrix. You multiply it with a weight matrix. So this is what is called. This is a linear transformation. Matrix. You just do a matrix multiplication, and after that, this is a linear transformation, and you apply an activation function that we will learn in the coming weeks. So today it's just a start for our course. You don't need to understand everything, but ask me if you don't understand anything. I will try to explain, but I will give you a lot of information that we will cover in detail in the coming weeks. Okay, so as an input matrix comes and we make a transformation, linear transformation, what is called we multiply this matrix with a weight matrix. And after that, there is a activation function that is for making it non-linear transformation. So it can understand complex features. If you don't make this activation function, and if you just multiply by matrix, and after another matrix multiplication, you at the end what you do is a linear transformation, and it is not enough. Because of that, we need activation functions. Okay, I will explain it later. So this is a transformation from one matrix. So this is a matrix from this matrix to another matrix. You make a transformation. In the another layer, you make another transformation, another transformation, another transformation. Each transformation is just a matrix multiplication followed by an activation function. Okay, it's a transformation. You just make transformations, and after that, these transformations follows, and at the end, here you have a vector, and each vector location corresponds to one person. So this is, for example, Joseph, this is Sarah, this is Uzay, and it says and these are probabilities. If the maximum of this probability is Sarah, then the output, so this, for example, it says that with small probability 0.1, it is Joseph. With high probability 0.8, it is Sarah. With 0.1 probability, again small probability, it is Uzay. In this case, this is Sarah. Since the maximum probability is Sarah, this deep neural network says that it is Sarah. The output is Sarah. And at the end, if this is a classification test, and there are some input labels and output labels, the true labels. You just compare this Sarah with if it is really Sarah. Okay. Okay. So what happens if you look at, so in the previous layers, if you look at what these are neurons, what these neurons learn. If you look at them, in the first layers, it understands the edges. So these are edges, simple edges like that. There is it understands if there is a hyperplane, there is a line, and if you are above this line or if you below this line, it just understands these edges, the previous layers. But hierarchically, then the network understands, the neural network understands in the middle layers, it understands some simple formations like circle, like triangle, like that. So it understands something bigger. And after that, in the next layers, it understands since this is a face detection problem, it understands what is an ear, what is a nose, what is the eyes, what is a hair. So it starts to understand again the sub parts of the face. And after that, in the last layers, now it becomes to understand the face. So this is a hierarchical representation. So, and it understands all this by itself. So this is called features. So this is a feature actually. Normally, before deep learning, so you need to have a feature extractor like this guy here, and he says that he just handcraft the features. So what are the features? What is an edge? What is a circle? What is a triangle? So it just writes the codes for these simple features. What is an edge? What is a circle? And after that, he also writes what is a nose, what is an eye, what is a hair. So he just writes itself. Then it gives this to the algorithm. So he defines the simple features like edges, like circles, like that. He defines it. But in the deep learning, there is no need a guy like this. The neural network can understand automatically on its own the simple features. So this is the This is the biggest difference between machine learning and deep learning. Neural network can understand simple features and the other higher or more complex features on its own. So there is no need for a guy like feature extractor. So is it clear on the is it clear the difference between machine learning and deep learning? So this is the most important part, because as you see in the deep learning, feature extraction and classification is in the algorithm part, but in the machine learning, feature extraction is at the human side. Okay, but it doesn't mean we can do feature extraction also to help deep learning. So there is a hybrid model. So a human and the deep learning algorithm can work together to make a better prediction. Okay, do you have questions about the difference between deep learning and machine learning? Okay, I want to show you this figure. If you understand, if you understand Turkish. So this is a caricature that I like. So it says that, so he says, Selamünaleyküm. What is this car? This guy says, and he says, this is the autonomous car of the Google, he says. And the horse says, first they get rid of us, now it is your turn, Orhan. The circle is shrinking, Orhan. So we are getting rid of the need for people. And algorithms can work on their own. Okay. So this is called automation of labor and job displacement. So for example, in the coming years, we don't need any call center operators. So when you call for example, a company, a telecommunication company, there are people that talk with you. In the coming years, there won't be any people. You will just talk with a digital assistant, and it will be a chatbot. It already become, but in the coming years, there is no need for people in the call centers. The taxi drivers also, since when we have autonomous cars, we don't need taxi drivers. So there are, with these advanced algorithms, there won't be need for many jobs to be done by humans. Okay. So and so what is machine learning? Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So they learn from the experience, they learn from the data. You just give the data, and from this data, it captures the patterns from that data. It uses statistics and computer engineering capabilities to catch the patterns in the data. So what we are using data set. The most important part is the data, not the algorithm. You can find algorithms everywhere. Even I will show you, and I will take a pre-trained algorithm for computer vision here. So algorithms, you can find algorithms. The thing is, the hardest part to get the data. Okay, so if you have a good data, an input data set that what you know, and you can transform it using the deep learning algorithm into an output set that is what you want to know. Like the properties of the house is the input set, and output will be the price of the house. But you need to have a huge amount of data for deep learning algorithms to understand that. And lastly, deep learning has really disrupted industry, research, everything. So before deep learning, for example, these are very different tasks. Computer vision is something very different than natural language processing. And it is very different from automatic speech recognition. And there are, for example, anomaly detection, fraud detection. Each problem is different, and we need different algorithms for that before deep learning. But with deep learning, magically, deep learning works better than the other standard machine learning algorithms in computer vision, natural language processing, speech recognition. These are the seemingly different problems, but deep learning can solve all of them if you have enough data. If you have small amount of data, you don't need to use deep learning. You can use other machine learning algorithms. And this is a very fast changing and new era. So every year, deep learning grows a new framework or a new algorithm comes to the birth. So we see new algorithms every year, even every month. So it is very hard to catch up. So it is a huge amount of discipline. It's a vast amount of information that you need to know, but I think it's worth it. It is the most powerful skill in AI, as far as I know, and most of the people will agree that. So it's very important. It solves many problems. So the knowledge in deep learning is very important. Okay, do you have questions? Okay, so I have sent you some online videos, some online video lecture series, and I really suggest you to look all of them. And other than that, I think we will use Pytorch because Pytorch is released in 2017 from Facebook. For the moment, I am also not familiar with Pytorch, but I plan to use Pytorch because it is becoming increasingly adopted by many companies and many research areas. So it is becoming the most popular framework in deep learning. So I will learn Pytorch and I will explain to Pytorch to you. But if you want to get a really quick start, you can use Keras library, which is much more easier than Pytorch. So you can look at Keras library to start quickly. Okay. So now I want to show you an example, image recognition example with a pre-trained neural network. So we don't train it; it is already trained, and it is called AlexNet. The neural network architecture is called AlexNet, and this is the algorithm that changed everything. So it is really started. So in 2012, there is an image recognition competition, very famous, ImageNet. So there are lots of images and many algorithms with many different architectures, different groups from universities and industry. They just compete with each other to win the prize. And AlexNet, before this 2012, deep learning was not popular. And this is the architecture that changed everything. And after this AlexNet, which is a convolutional neural network, a complex network, deep neural network. After this, AlexNet won the prize. Everything has changed. Everyone starts to give attention to the deep learning. And after this, people all over the world, researchers all over the world, started to work on deep learning again. So there are, winters of AI. In some areas, in some period of time, people all over the world really worked on deep learning or machine learning or AI. But there are some periods that they cannot move it further. They cannot develop or increase the performance of the algorithms. And after that, they understand that we are stuck and we cannot do anything more. And the funds, the money for this research is cut. So because of that, there are periods, three periods in the history of AI that AI is stuck and nobody worked on AI. And this is the last time that they find a really good algorithm, a really good way of thinking, and they change everything, and the winter of AI is finished, and we can say the summer of AI has started after 2012. So nobody was really taking into account the deep learning before AlexNet won the prize, and after that, people from all over the world, they started to work on deep learning, and after that, everything has changed. Okay, now it is very easy. I will show you how to use AlexNet. So this is a very important algorithm, and it is the first time also I use this algorithm. So this is we are using Python, as you know, Python 3, and this is an environment called Jupyter Notebook, but in the cloud, Google Cloud. So you can run your code in the Google Cloud without installing any frameworks, any Python, any other things, because you do all things on the Google Cloud. So I encourage you to start with Google Colab, and you have the code, I suppose. So we are using Python and Pytorch here. Here we are importing some libraries. This is I found from the internet the ImageNet class. This is a TXT, and it shows us the class. There is 1,000 different images. So there are dogs, cats, different types of dogs, different types of cats. So these are the animals here. Okay. Now, so this is our we didn't use anything here. It is just the names of the output. So for example, I told you that maybe this is the labels. So this is Joseph, this is Sarah, this is Uzay. Here we have 1,000 output, and each output, the first one corresponds to the tench. The other one is goldfish. The next one is great white shark, like that, tiger shark. So these are the animals, and we want to predict. When we give the image, we want it to predict. So this is just the labels. We didn't do anything here. Okay, it's not important. Now we are from Pytorch. So this is UC. This is the AlexNet. We get the AlexNet pre-trained. We don't do the training here. This is the first course, and we just want to see something fun and creative. So we are taking a neural network, the AlexNet neural network. It is a convolutional neural network. I don't show the architecture for the moment. We will see it later, I suppose. So this is the AlexNet. You just get it from the internet, and it is already pre-trained. Now you will use somebody else's code. This code is already pre-trained and prepared for you, and it takes this is the properties of the code. Okay, now I will take an image. So for example, so this is an image I will show you. So from the internet, I just find some image. You can also do the same thing. So this is a dog. This is a special type of dog, and it is boxer. Okay, so this is a boxer. So we want our AlexNet to recognize this dog and the breed of the dog. So what is the breed of this dog? Is it possible? So here from the internet we take an image. Okay, and we already taken this model, which is AlexNet. This pre-trained, and we will give this image to the AlexNet, and it will say if it is a dog or cat or any other class. Okay, so okay, it doesn't show the image. So here, so this image has some different height, some height and some width. So this is a different height and width. But this AlexNet has a special, it needs the height and width to be, so it's special or specific height and width. So we need to resize our image. So I will be honest with you. For the moment, I don't know really what is going on here. but I will learn it and I will explain it to you later on. So this is just when you have an image, it has some different size of height and width. What it does is it transforms it to the correct height and size, because you know here when AlexNet the input size must be specific, so you cannot give any input size. So if it is different from what you expect, then you just resize it and crop it if it is necessary. So and you give it to the neural network. Okay, so this is just input image is resized. Okay, so this is a pre-process. So you do the pre-processing to this image, which is this one. Okay. Okay, then you give this pre-processed image to the model, and model outputs something. Okay. So let's look at what it outputs. Sorry. Here, for example, if I want to add a code, I just write here. So what is the output? I want to see the output. So output is a lot of probabilities. So these are the probabilities. So and we have 1,000 probability because we have different 1,000 classes. Okay. So here, this is the output, which is the maximum one. As I told you before, for example, here in this case, this is 0.1 Joseph, 0.8 Sarah, 0.1 Uzay. So which is the maximum probability? We need to understand which is the maximum probability. And we will say that if this is the maximum probability, then we will say that it's Sarah. We will do the same thing here. There are 1,000 categories here. For each one, there is a probability assigned to it. So we need to understand which is the maximum one. So sorry, here these are unnormalized scores. There is another transformation we do to get probabilities here using this softmax activation layer that we will see later on. So today you don't need to understand everything. I'm just showing you a pre-trained algorithm, and it can or cannot understand 1,000 class of different images. So it is image recognition example. So here, what is the maximum one among these 1,000 probabilities? Which index? I don't know if it. Okay. Okay, why it is not finished? I will run it again. Okay, I will run from the beginning. Restart and run off. Okay. Yes. Okay. So here again, it has downloaded the pre-trained AlexNet. Okay. So why we are waiting? So this is the 242. So what is the 242? So these are the labels. If you look at it, okay, it says it is boxer. Okay, now let's give another image. So let's give this image. So this is another image. Let's look at what is this image. Okay, so this is another type of dog. Okay, so now I will give this this image to the neural network. Okay, so it will make the necessary transformations. It will output. Okay, now it will change, I think, to another number. So it is 258. So what is the label assigned to 258? So it is called Samoyed. I don't know what the Samoyed means. So let's write it, Samoyed. And if you look at the pictures of Samoyed, as you see, so it is the type of the breed of the dog. Okay, so so here we make a brief introduction to deep learning, and we have already used a pre-trained image recognition algorithm on the run, as you see. So this is the model building part. Okay, I will write a text. So what you have seen is model building. Actually, for the moment you don't know how to do model building. We will see in the coming weeks. So you have a neural network. You need to design the architecture of the neural network. And you need an optimization algorithm because you need to optimize your weights in the algorithm. You need to decide which optimization algorithm. So actually, first of all, the first thing that you need is the data. You need a data, and because the neural network will learn from the data, so you need a special architecture of the neural network, and you need an optimization algorithm like gradient descent. And after that, your algorithm will learn the correct weights for this special task. Is it finished? And what do you get? At this point, what do you get? At this point, you will have this model like this one. So this is a model. Here we can, since this is our first lecture, you cannot understand the details here. But this is a special architecture and of neural network, and it is a pre-trained neural network, so we have the correct weights. So in this part, now you have the model. And after that, when a new test image is given to you, you can make prediction. But all this called is model building, and you will have a working model. But there is also model deployment, which is also very important. So if you do not, after building your model, if you do not deploy your model to a web service, it will not work. So we will need so in a web service with an API, with microservices like that, you need to build a website, maybe in Flask API or Fast API, and when a new image comes, this web service should predict in the real time the class of the here in the image recognition case, class of the dogs or other animals. Okay, so we will heavily see, and in most of the courses you will see model building from a data with a special architecture of neural network and with a special optimization algorithm. You learn the weights and you train your neural network. But does it finish there? Is it finished for you? Unfortunately not. After that, you need a computer engineering skills that is called DevOps skills. And it is now called, it's development and operation skills to take your model in the live. So it will work online. It should work online. So model deployment is also very important. So if, I don't know if I have time, maybe I will show you, or maybe in the projects I will want from you to deploy your models in a web service. And for that, you need to, so after you have a model, you learn the weights, you need to transform it to a web service, and you can put it to a cloud services. So maybe you can use Google Cloud or Amazon Web Services or Azure, like that. So I think we will have a guest lecture in the coming month, and he will show us how to run neural networks in Amazon Web Services. So if you have the knowledge how to build a model, and if you know how to deploy a model, then you are ready to make an AI service to other people. And this is the most important thing for computer engineers from my point of view. and we will try to see those things. Okay, do you have questions? If not, I want to finish our first lecture, our first interactive session here. And maybe in the Wednesday, we can start to learn this gradient descent algorithm. And we can make an introduction to Pytorch. I don't know, we will see. So again, here, gradient descent is how you learn the parameters of the neural network. So this is about optimization of your neural network in the model building part. Okay, do you have questions? Will you make the groups? No, I will not make the groups. You will self-organize. Is it possible for you? If you cannot find a group member, then you can send me an email and I can make the group for you. But I don't want to do it for you. I want for you to self-organize and form groups. Okay. Is there other questions? Okay. You upload the recorded lecture. Why not? I think I will. Okay. Okay. Do you have other questions? Can I ask you something about schedule? Yes, please, Ilyas. Yes, please.
Hocam merhabalar. Sesim geliyor değil mi bu arada? Alo.
Yes, I don't hear you.
Hocanın sanırım ses kapalı ya da kısık, bilmiyorum.
Okay. Ben duymuyorum. Neden duymuyorum? Acaba? Bakayım. I don't hear. I don't know why. Bir dakika. Select the microphone, select the speaker, build an output. Create a spreadsheet for us to find groups so we can find people in the course without you. Okay, Mehmet Ali. So maybe we can do it in the in the next week. Sorry. So you have time. Actually, we have time. We can do it in the next week. Mehmet Ali, just remind it to me again. We can. Okay. Okay. Do you have other questions? So this is as you see, this is our program course content. So we start with gradient descent and optimization. We will see linear and logistic regression, and then artificial neural networks, and we will see word-to-vec algorithm. So these are the fundamentals of deep learning, and after that, special neural network architectures begin. Actually, word-to-vec and AutoEncoders are similar in some sense, and they have a special architecture. Convolutional neural network is another special architecture, and this is used for image recognition. So this is, for example, this is used for image recognition. In the AlexNet, you have convolutional networks, and we will see sequence analysis with RNNs and LSTM. So these are especially good for time series analysis, natural language understanding. So this type of neural network, the different type of neural network is used for other things. For example, autoencoders. With autoencoders, you can make dimension reduction, and you can use it for anomaly detection. Okay, so these are special neural networks. We will see. Actually, we don't have a midterm. I think I will change. I need to change this. We don't have a midterm. Sorry. No, excuse me. We have a midterm. We have a midterm and we have a project. Sorry. I just actually I need to verify our course content. So this is I will tell the final thing to you. Okay. That's okay. I will upload the videos, Ilyas, so you can look at the videos and you can ask me any question in the interactive session or via email if you have questions. Okay. For the moment, if you don't have any other question, I want to finish the course. Okay. Thank you for everything. Have a good care of yourself. See you later.